Hello and welcome to the section of the Calculus 1 tutor where we're going to continue working with extra practice with integration. And in this section we're going to continue working with integrating trig functions. Just a little more work getting to the answer, usually because of the simplifications involved. So what if you have the integral of pi over 3 up to pi over 4 of the following function? 3 times the secant squared of theta plus 4 times the cosecant squared of theta d theta. The first thing I want to say is, if you haven't, I've already said it before, but just to make it clear, don't get scared if you see thetas here. I mean, this is just dummy variable, right? So we're integrating over theta d theta. Same thing as integrating x over dx, same thing as integrating alpha over d alpha or anything. They're all just variables signifying what you're integrating over. It's a symbol. It would be the same thing as just having x's everywhere, right? So don't worry too much about what it looks like. Now, let's go ahead and tackle this guy. So this is have a 3 here, so we can pull that out. The secant squared, integral of secant squared, we know already is tangent of x. So we'll say tangent. Of course, we're dealing with theta, so we'll leave it in terms of theta. And then we have plus 4 from here. What's the integral of cosecant squared? That's going to be negative cotangent. So let's go ahead and write it as a negative. Let's put a negative there. Cotangent of theta. Integral pi over 3 pi over 4. So believe it or not, the calculus part is actually finished. We've taken the antiderivative. All that remains is to plug in these limits of integration, evaluate these trig functions properly at those limits of integration, and then do all the simplification to the final answer. So you see, the calculus concepts really aren't that hard. It's just the idea of actually getting to the answer that, can get a little, I don't want to say hard, but definitely a little bit challenging if you're not careful. So we want to do one step at a time. So let's open up our bracket and let's say 3 times the tangent of pi over 4, let's write it like this, minus 4 times the cotangent of pi over 4. Okay, we'll even wrap this in like little parentheses just to make it easier to read. We'll close this bracket off and we will subtract off, evaluating it at pi over 3. So what we'll have is 3 times tangent of pi by 3 minus 4 times the cotangent of pi by 3. Close the bracket. So there we go. We have everything written on the board. Now we just need to actually pull it off. So what do we have here? 3 times, what is the tangent of pi over 4? If you think about it, the tangent of pi over 4 is 1 because tangent is sine over cosine, right? So sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2. So sine over cosine is going to give you 1 because the top and bottom are the same. It's just an easy way to remember it. So I'm going to put a 1 there. Minus 4 times. What would the cotangent of pi over 4 be? See, a lot of people would look at cotangent of pi over 4 and maybe they're not sure. But if you think about it, cotangent is just, instead of sine over cosine like it is for tangent, cotangent is cosine over sine. And again, since it's pi over 4, the cosine of pi over 4 is square root of 2 over 2. The sine of pi over 4 is also square root of 2 over 2. So cosine over sine is going to give you 1. So basically you're going to get a 1 in this field also. All right. Then over here you have 3 times, what would be the tangent of pi over 3? Now, there's a couple ways, some people actually memorize what these are. That's fine. In all of my years of doing math, I never actually memorized tangent of pi over 3 and cotangent of pi over 3. I always memorized sine and cosine of the core